I was looking through Twitter recently and I came across this tweet that said the hottest new programming language is English. Now I thought this was a little bit odd. I would have thought it would have said something like Python or JavaScript based on the developer surveys we see every year, but no. Now what do they mean by this? Why English? Now, I'm sure you've seen there is a huge rise in these AI coding assistants such as GitHub Copilot, Cursor, and others, as well as just using large language models like ChatGPT and Claude to be able to just tell it the problem that you're having in English, and it will write a solution for you in a programming language of your choice. In theory, this will help speed up development. Now, some of the tedious problems you can describe in a very natural way, and the AI assistant here will write the code for you. Now, this got me thinking, if these large language models are so good, does that mean that you're now not bound by the programming language that you're familiar with? Now, for me personally, I'm a Python guy. I've been writing Python for many years, and it's what I feel comfortable using. If you asked me to jump into Go, for example, I wouldn't really know where to get started other than how to say hello world. It would take me a little while just to get familiar with the syntax. But does this now mean with the help of these large language models, I can now write Go and maybe now access some of the performance advantages that a language like Go has over Python without having to know any of the language? Let's have a look into this and see if this is possible, or if all of the hype around these AI assistants is just noise and there isn't anything behind it. Now, my first challenge for these assistants was to take this JSON, which is a JSON full of execution data from Kestra. It's got lots of different executions, including all of the tasks run during those executions. Now, what I'm curious to do is see, for the flow make data, there's a task in here called Python, and this task took a good amount of time to run. As you can see here, sometimes it took a while, sometimes it didn't. So I'm curious to see how long this took to run across all of the executions on average. So a fairly straightforward problem, but something that performance could be hit because the size of this JSON is fairly large. So let's see if these AI chat assistants can manage this. So here I've got ChatGPT open. I'm going to use the 4.0 model here. Potentially 4.0 mini high would be slightly better, but I'm just going to keep it generic here. I've got my JSON file and I'm going to ask, I have a JSON file that contains a load of data about executions of a workflow. I want to understand how long it took on average to run the task ID Python across all of them. Can you write me a Python script which can produce this result? Now, I've made this fairly easy for it by telling it the property is called task ID and that it's called Python. I could have maybe been a little bit more natural in the way I spoke here, but I'm going to press send and see if it will produce me a Python script for being able to get this result. Now, instead of using a library to do this, it's decided to do it using regex, which is maybe not the cleanest way. This is a good example of where maybe this is a tad unnecessary. I personally probably would have used isodate to just convert the duration format into an object that I can then get the time from. It's going to then load the JSON and then it's going to loop through everything and get the result. This feels very long for something that doesn't really have a ton of computation. For context, I asked ChatGPT the same thing, but without saying produce this result yesterday. And it didn't give me a Python script. In fact, it just calculated the output for me. So that was interesting. Secondly, I had to ask it for a Python script, and it did use isodate here, and the script is a little bit shorter. So a little bit bizarre, these differences that you get from asking the same question on different days. But yeah, I thought I'd share that. Okay, so we've got our Python script, so I reckon it's worth now, let's try running it and see what happens. Okay, so I've just tried to run it, and as you can see, it has failed because it's tried to do a .get function on execution. Now, let's have a look to understand what this is. So data is the JSON that we're loading in, the JSON that looks a bit like this, and we've told it to get task run list, but it doesn't know what that means. Okay, so I've had a bit of backwards and forwards here with ChatGPT. I'm not convinced it's necessarily read the JSON fully. If we have a look here, it doesn't understand what we're doing. It hasn't actually looked at the JSON I've given it. The JSON I gave it starts with results, but the JSON it thinks it starts with executions. So I don't think it's actually read the file I gave it. So it's going around in circles here, and it hasn't given me a solution. Now, we're going to have a look at the solution that I got from when I demoed this yesterday before recording this video, where it did work. So I've just run this now for the code that it produced yesterday. As you can see here, it's a little bit simpler here, where it knows that it starts with results, and then it can get the task run list and go on. So I think all of this issue stems from the fact that it hasn't actually read the JSON file I gave it. Little bizarre. Now we can continue playing with it, but I think the takeaway from this is don't always rely on what it gives you. Luckily, because I know what's going on here, because I, given it this example as sort of an experiment, I could identify what the problem is. But if I was using a programming language I maybe wasn't familiar with, or maybe doing something out of my depth, I wouldn't necessarily know how to guide ChatGPT. So I've just gone back and asked it that the JSON starts with results. Again, massively complicating things here with this past duration function. It's finally understood that we start with results. So in theory, this example should work now. So let's have a go. And there we go. It has successfully worked now that I have told it the correct format for the JSON. So again, bit of AI hallucination where I gave it the data structure in raw format. It understood some of it. It didn't understand all of it. It managed to jump into the complicated bit and completely miss that the first level of the JSON was results rather than, executions. I don't know where I got that from. Now, this is the next interesting thing here, right? Is I can now ask this to convert it into Go. So can you write this in Go now? So now I should hopefully get Go code that will now do the exact same thing and get me the exact same code. And again, I ran this example yesterday, so I'm curious to see how this compares to what I got yesterday. Now, we can see that it's understood that now that we understand the JSON format, it's understanding that it starts with results. We've just told it to run our new Go code, and it's given us the same 12.05 seconds that we got previously. I can also run the Python one. Again, same result. So that gives me, without looking at the Go code too closely, it's reassuring that it has done the same thing. But as we can see here, there's a lot of code here, 80 lines of code. The Python was 34. My original Python one was about 30. So, and and we can see the one that it originally wrote for Go yesterday was about 82. So interesting to see. Obviously, this didn't take very long to run. So I am curious now to see if we look at a slightly more intense example, something that's got to process a CSV file that's massive, it's going to take more than a second to run. Do we see a performance difference where we can just change language at the click of our fingers? I don't know. Let's have a look. I want to run a workflow that's going to process a CSV file. What I wanted to do is take all of the different properties and create a unique ID for each row using an MD5 hash. Now, I did this inside of the Zoom camp that we ran back in January. So if you want to see how we did that using SQL, then I'd recommend checking that out in the description below. But I'm going to use Python here to generate that unique ID. What we found back then was, because there's a lot of data, it does take a while. And so I'm curious to see how long Python takes, and then to look at whether Go does offer some performance advantages, and it's worth maybe changing to Go. Now, here's my workflow. It's going to take an input file. We're going to then take that into a Python task here where I'm going to install pandas. I'm going to generate a CSV file called outputs.csv, and that will have my unique ID. What we need to do now is go and find one of our chatbots, ask it to produce code that can solve this problem of taking a CSV file, taking all those columns and generating an MD5 hash called unique ID as a new column, and then save that as a new CSV file. I've got a really cool way of testing the performance of this so we can see how quickly it runs over 100 runs without having to run the code that we just wrote. So I've got this performance tracking script here that's pretty nifty. We can tell it which workflow and namespace we want it to run in, how many runs we want it to do, and then we can just select which language, so it's easy for us to see in a label later which one it ran. Now, when we go down, we'll see that it's going to download that chunky CSV file, and then we're going to then just use a for each loop here to just keep calling subflows of that workflow we've got that's going to actually add the unique ID. And it's going to keep doing that for as many times as we told it to. And then once it's finished running each of the individual executions of the make unique ID, it's going to then get the duration from the execution, and then it's going to calculate it. So it means at the end, what we'll get is an average for how long it took to take that workflow. Here's a quick sneak peek at the CSV file we plan to use. As you can see, this is for context, this is data from the New York taxis. There's lots of different data such as pickup time, drop-off date, and we're going to use a bunch of these to then calculate a unique ID. Now, as you can see, there is 630,000 rows in this CSV file. It is fairly large. We can see inside of Finder that it's 57 megabytes. That's pretty large for a CSV file. So we're going to use Kestra to help us here to automate the process of being able to figure out how long it took. So now let's ask ChatGPT how to do this. But there is a caveat. I'm not going to give it the CSV file, and instead I'm just going to tell it the structure and let it figure it out. Hello, ChatGPT. I have a CSV file for you that I want to add a column to that contains a unique hash. It's going to create that unique hash using vendor ID, the pickup date time, the drop-off date time, the PU location ID, the DO location ID, the fare amount, the trip distance, and then use that to create the MD5 hash called unique row ID. Can you write a Python script to do this? I think that's fairly clear. I think it's very obvious what I want it to do. It doesn't need to know what the data is necessarily. So let's ask it away and see what it can produce. So here, it's generated us a snippet of code. We've got a generate unique row function where it's going to take each of those properties that I described, and it's going to then combine them to create an MD5 hash. All looking okay for now. And then afterwards, it's going to just use pandas to simply just add a new column, add that unique ID to it, jobs are done, output. Shall we see if it works? I'm going to copy this now, and I'm going to then add this back to VS Code. Now, like I said yesterday, I've already done this example before, and I'm curious to see how today's version of the code compares to yesterday's. So let me just put unique.py. I'm going to paste my code in here. Now my CSV file is called green trip data underscore 2019-01. And the output, I'm just going to put Python new. So now if I do UV run, well, actually, does it need any libraries? It does, but I already have pandas installed. So we're all good in that regard. And I'm just going to do UV run unique.py. Now, as you can see, this is going to take a little bit of time to run. And I'm going to check it works locally before putting it into Kestra to do some performance improvements. So we can see it took a fair while to run there. Took 10 seconds, it reckons. Now, let's have a look at the data. So here we've got our new CSV file, and it's got these unique IDs on the end. All looking good so far. And we can see that if I go all the way across, unique row ID is in fact a column. So now let's have a look to see if Go can do this any faster and if the results are any different. I've asked it to write it in Go. Let's see what it does. Now, the thing that makes Python so appealing for something like this is, as you can see, you've got to write a lot more Go code to achieve the same thing, having to handle the files, add the new rows, add the new column. It's all a little bit more faffy, whereas Python makes it so easy with pandas to be able to just go, just add it, just do it. So that's why developers use Python, because the developer experience is normally quicker and easier to then deal with this data, even if the performance isn't as good. But this is where something like ChatGPT could allow us to then rewrite everything in a different language once we're happy it works in one. So we've got the code now inside of VS Code. I've updated the input and output file. I'm going to press run now, and we're going to see how long this takes to run. That was very, very quick. That didn't take like any time at all. So now, shall we have a look to see if the code is any different? So we've got unique IDs, and it looks like it's done it for every single row. However, I don't think that's the same as the Python. Let's just open both side by side. That's not the same. Those row IDs are different, but they should have been generated on the same data. So something's gone a little bit wrong here. Now, not every row is wrong. As you can see, row 7 looks the same in Python as well as Go. So what's going on here? Now, I actually wrote a comparison script here that will help us figure out what's going on. So I'm just going to put the file names of our new files in, and I'm going to just run our code, and we're going to have a look to see what is actually different. There are nearly 20,000 rows that have matching IDs, but 43,000 don't. Don't you find that a little bit odd? Maybe we shouldn't trust these chat agents as much as possible? I don't know. Before we go a little bit further, I'm going to get this to write it in one more language. So we've got a third example to see which one is fibbing. Is it Python that's having the issue, or is Go making the IDs incorrect? So now I'm going to ask, can you write it in JavaScript? And we can run it with Node to see what happens. Now, I wouldn't recommend doing this in JavaScript. JavaScript probably isn't the fastest language in the world, but a lot of people know how to write JavaScript. So let's have a look. So we've got to wait for it to write our code, and then we'll have a look. But there's definitely something fishy going on here. Okay, so we're going to run the JavaScript. It's taken a little longer than the Go, potentially longer than the Python, but it took 7 seconds, so actually not too bad. But let's have a look and compare this to the Go and the Python. So the key thing was that first row, right, was 63D. Go was 56522, and JavaScript was also 56522. So let's run the compare now on the JavaScript and the Go and see if there's any differences between those two and understand what's going on. Interesting. Okay, so JavaScript and Go have both generated completely the same unique IDs, which would suggest there's something going on with the Python script. Instead of investigating ourselves, I can make a hint myself. It's to do with this. What we'll do now is we'll tell ChatGPT that it was wrong and to work on it. JavaScript and Go had the same unique IDs, but Python only had a third of them the same. So ChatGPT has realized that languages don't actually always handle strings the same way. It reckons that Python is concatenating them as is, whereas the others are not. So instead, we should do this for the getUniqueID function. So now, let me just copy this. We now go over to our unique.python, and I'm just going to paste that in. So now, it's going to get each row, and then it's going to concatenate them and strip them, make sure there's no white space, because any white space or anything like that will cause a different hash. Another thing that it's changed as well is under the read CSV file. Here, it's going to force everything to be a string using this D type. So let's make sure we add that in as well. And the other thing we need to add as well is this row that is going to, as it says in the comment, replace any not a number or anything like that with an empty string. So again, consistency. So now with that in mind, let's run the unique one more time. Let's see what the difference is compared to the Go and JavaScript files. Looking promising. 56522 is the same as we saw from JavaScript and Go. So now if I run the comparison, which is going to look at Python and Go, so we do uv run compare, we should hopefully see everything is identical. Wonderful. So what have we learned from this exercise? The code that you get from ChatGPT may not be as accurate as you may expect. Even though I told it to write exactly the same thing, it doesn't actually test the output. I maybe could have asked it to test the output and make sure, but just because it generated it doesn't mean it will work. The first example we showed, it didn't look at the JSON format I gave it. The second format, it didn't actually look at, well, I didn't give it any of the data, but it didn't do any sort of safe checking to check if there's any gaps or what if this, that, and the other. It just assumed everything was in form and everything would work. The only thing to do now is to see, was this all worth it for the potential, we don't know yet, for some performance advantages. So let's jump into Kestra with our new code and have a look at this example. So I've just added the Python code here to Kestra. So now we can automate this by just having it automatically run 100 of them without us having to do that and calculate the time it took to run the whole thing. Now we could get just the Python task, but because it's just the one task in this workflow, I'm just curious to understand how long that takes. I've also got the Go code set up here too, so I've now got 2 examples that should work no problem. Now, if I now head over to my performance script, which you can find in GitHub if you'd like to have a play with it yourself. We can see here it's preset to use the Python one, but we could rewrite that to use the Go one if we want. Okay, so I've got both of my workflows, the Go one and the Python one set up, so they're going to use the correct file names and whatnot. So now all there is to do now is tell Kestra to run our Python one 10 times, and we can see how long it takes on average to run that. So at first it's going to set a label so we can easily see this was the Python one. It's going to download that CSV file, and then it's going to start running the Python code 10 times. Every time it runs it, it's going to get that duration data and then store it so we can look later and understand how long it actually took to run these 10 executions. Now, the reason to do this 10 times is there are a number of different factors that can impact execution time, and the more we run it, the more we reduce those variables that might make one run take way longer than another. So as we can see here, it took about 24 seconds to run it in Kestra. Now, it's worth noting that these are all using Docker task runners so that we can create an environment for Python and Go to work. But you could look at running them on a process task runner, which will run it as a sub-process on Kestra, so no container, as a result, a little bit faster. But for consistency, we're going to run both in Docker. Now, again, it's taking about 24 seconds to run that full workflow. We'll sit back and see how long it takes, but based on this, it's not looking hugely fast. Okay, we finally got to the end. It took about 4.5 minutes to run those 10 executions. Now, jumping to outputs, we can actually have a look to see that it took about 22 seconds to run that Python script. Not the quickest in the world. Now, I ran the same example, but with the Python code generated from yesterday, and it got 17.7 seconds. So a little bit faster, but still taking around that 20-second mark. Now, let's have a look to see how long it took Go to do the exact same thing 10 times. So let's press execute, and we can see already, once it's downloaded, that the subflow is going to take way less time. We saw that on our local machine too. So there we can see it's taken half the time it took for that original one, and most of that will be the Docker container setup. There, under 10 seconds. So there is a big performance advantage we can gain by running this using Go. So it does beg the question, is it worth experimenting with these large language models to potentially use faster programming languages? Potentially. Now, Go is just the example I've used here, but loads of different languages have different advantages, such as C, C++, Rust. They all have advantages that you may not want to write because there's a few more things you have to do, but they may bring performance advantages where they run faster. We can see here, it's already halfway through and it's only been running a minute. So if this was a sort of workflow that maybe you needed to run every hour or very, very regularly, and to get that data is important, then there could be advantages here. But I do think if you are going to do anything on a much larger scale, something that's getting more wieldly, it is important to understand what's going on in your code. Because as we saw from that original Python example, it did in fact get it wrong. And if it wasn't for the fact that I checked it, I wouldn't have known it got it wrong. So it is worth knowing that there is the potential for AI to make mistakes. It's not foolproof, but it can be a big aid in helping you. For example, I've written a load of different scripts in 3 different languages today, and while I didn't write them necessarily, I did get assistance, and I did spot when there were problems. So if we can see here, let's go down to outputs, we can see under calculate, it took on average 9 seconds. That is half the time it took for it to run in Python. And if we go back to executions, we can actually see the same for when I ran it yesterday. It also ran it with yesterday's code. in 7.7 seconds. So there are definitely performance advantages to be had. It's just sometimes the risk is not worth it, where you now jump into a world where you're not familiar with the code base. So is English the hottest new programming language? Potentially. Especially as time goes on, we're going to see advancements in these large language models. These coding assistant tools are going to get better. And it's worth noting, I was just using chat models instead of using these plugins for things like VS Code, where they can read your whole code base and they can analyze it. Potentially that would have been more accurate. Maybe I should do a video on that. If that's something you'd be interested in, let us know in the comments below. But right now I think, yes, these tools are very helpful, but you do have to proceed with caution, and it's definitely not foolproof, but it's definitely exciting to see where the future's going to go.